So our agenda today, as usual, is going to be we're welcoming our participants in, and we're going to go ahead and also introduce the organizers of the Abuja R User Group and the R Ladies Abuja, because they joined webinar today. So then we'll introduce our speaker, and also we allow him to go through the workshop as planned. Then we'll entertain questions and answer. So I'm going to go ahead to introduce our honorable speaker and teacher today. So he is, sorry, I think we have an issue here. Sorry, I think there's been a background noise here. So I'm going to go ahead to introduce Wolf. So he's going to be the main person on screen now. So Wolf is our speaker for this month. So he's a radio and TV technician and a sociologist by training. At university, he worked with SPSS and Startup. His first contact with R came in 2007 when he worked for a small company that thought about avoiding the SPSS license fees. That's funny. So after a 2-day workshop, he vowed to never open the R software again. It took 7 years to start the next attempt. That's really, really awesome to know there. So since late 2014, Wolf has been working his way into R and never looked back. I think we have something similar there. So much, so much. So now he focuses on workshops and training, mostly online since 2020, after many in-person workshops since 2017. So Wolf will be taking us through a comprehensive understanding of the purrr package. So we're really honored to have Wolf join us today, and we really appreciate it. And we're looking forward to gaining from your wealth of experience as an R user. So we're looking forward to gaining from that today from you, Wolf. So thank you so much. I'll hand over to you to go ahead and take us through the class at the workshop. Thank you.
Yeah, thank you so much, Ilikisu. I feel really honored and humbled to be invited for this talk. You must have done such a great job in organizing this event. I went to the event page and I was really stunned by the number of registrations. So you must be a very good networker, and it's great to see such an active community. So thank you. I'd like to share my screen if you'd let me. I'd be thankful. Okay, thank you. Let's see. Okay, so yeah, thank you so much. I'm really looking forward to this, and I'm keen to see how we go along. So the topic is functional programming using the purrr package, and maybe some of you have been introduced to the tidyverse. So I think it's interesting to see purrr as part of the tidyverse, but it seems to fly a bit under the radar. When you look at the vignettes, at the documentation, it's surprisingly badly documented. There's only one vignette in the package, and it's not about a main topic or an introduction to the package. So I was once in contact with our studio team members, and Jenny Bryan told me the idea is to make data analysis possible without the purrr package. So it doesn't feature so prominently in the tidyverse, but it's a powerful package that allows you to do quite interesting and powerful things. And I hope to show you some of these today. Maybe before we dive into the topics, let me introduce you to the workshop material. I show a presentation on screen. This presentation will be shared after the workshop. I will make it available, the slides, so you don't need to take too many notes, and you can relax and look at the screen and follow what we do. Oh yeah, and I try to keep an eye on the chat. So if I miss any questions on the chat, you can always interrupt me and point me to questions that are there. Thank you, Billy Kiso. I see that you just posted 2 links there, or the link to the RStudio Cloud project. So there are 2 options how you can participate today. One is to work in the browser. There's an RStudio Cloud project prepared there with the packages already installed. So you can start out straight away. You need to register an account there, but a free account is fine. So no payment required. And of course, it's also possible to follow on your own local machine. And there's a link to the course material. I'll try to put that in the chat as well. There's a cloud folder, and after the workshop, I will also add the presentation there. So that link is in the chat now as well. So let me show you quickly what is part of the workshop materials. We have 4 R scripts, Abuya 1 to Abuya 4, so they're numbered. The code that I show during the presentation is in an R script, and you're invited to follow along there and try out the examples. Oh yeah, Bilkis also posted that link. Yes, so there are 2 links, the RStudio Cloud link and the link to a different cloud that has just the R scripts if you don't want to work on the RStudio Cloud, but on your own machine. But those of you who just want to watch and listen, that's also fine, of course. Nobody is forced to try out any exercises. It's just an option that you're welcome to try. So we have this script from the presentation. I will stick with the presentation later on, so you can follow along in this script, Abuya 1 code from presentation.r. And then there are 3 other scripts that we can go into a bit later after the main part with some special purrr functions. There's also a data set in RDS format. So that should be in your material if you downloaded that, and it should also be in the cloud, magicnumbers.rds. So you can just click on that. If you're working in RStudio, there's also a function read RDS to load that data. You need to assign it a name. When you click on it in RStudio suggests a name, magic numbers, so you can use that. We'll look into that later. I'll say more about what is meant by this magic. But for those who want to try along, there's some inspiration, some magic numbers that you can try out for the examples. So if you lack intuition for magic numbers like me, you can use that data set to get some inspiration. Right, so I'm going back to the slides and welcome you to follow along. So I promised you to bring in some magic. So what kind of magic are we on for today? It's the purrr package, of course. So purrr has this cat on the hex sticker. And purrr is, of course, the sound, as we say in English, that a cat makes when it is happy. And so how do we see magic today? I will use it twofold. And the one sense is the functions in the purrr package can appear a bit magical. So I hope you can get into that a little bit. And the other aspect is the magic numbers, because we want to generate messages from random samples of letters of the alphabet. So this is an example that I find intriguing for illustrating the functions. If you wonder how you can use that in real world examples for your own data analysis project, of course, we will discuss that, and we'll see other examples later on that do not involve magic numbers. But I think it's a nice way to start. So these are the 2 senses of magic that we want to go into today. Maybe a little anecdote of the purrr package. Before I clicked on the presentation today, I had a few more minutes and I had a newsletter from our bloggers. And just today I found this article about the purrr package, and it was spelled with 2 R's. So the writer of that article missed the 3rd R in the purrr package. And I want to share with you a little anecdote why the purrr package is spelled with 3 R's. So Hadley Wickham once gave a presentation, the author of many tidyverse packages and of the purrr package as well. It's a team effort now, of course, but Hadley Wickham has initiated a lot of these packages. So he once said in a presentation, you'd be surprised to know how much time I spend thinking about things like this. And he started typing. When you start out loading some packages, maybe dplyr, maybe tidyr, for example, readr, and then comes the purrr package. And you see when you spell it with 2 R's, it doesn't write a line. It's one letter is missing. So that's one of the reasons why he used 3 R's for the name of the purrr package. Of course, the other one is the sound that the cats make, a drawn out R sound, and also, yeah, maybe 2 R's for the sound and 1 R for the programming language R. So that's why we spell purrr with 3 R's. You don't usually have to load it because it gets loaded when you load the tidyverse. And then purrr is part of that. Right, so what do we want to do today? Please don't be shocked when you see this slide. If you don't understand this code at first glance, then don't worry, we will work our way into this step by step. It's just what we want to achieve today in the first part of this session. So we have a function from the purrr package that we will get into. In this case, it's the pmap character function. So we will see what that does. And it takes a list of vectors. So the key idea here is that we want to iterate over several vectors at once in one R command without writing a loop. So this is the key trick that I want to show you today. We have 3 vectors, seeds, choices, and word lengths. We'll work our way slowly into that, so don't worry about that now. And we will apply one function, and here it's called magic message to create a message from random samples of letters of the alphabet. And then talking about cats, you saw the cat here in the purrr package hex sticker. Talking about cats, we also use a function cat. Of course, this is a bit of a coincidence. The cat function here, maybe some of you have seen it. You can use it to print something to the console. And usually when you print to the console, you have these quotation marks, and the cat function prints out a message without the quotation marks. But we'll see that in action later on some more. So the cat function here accompanies the purrr package. Right, so this is what we want to get into, but we build it up slowly, step by step, so relax. The message is happy B-Day to you in 2022. Birthday would be a bit too long to build up from random samples of letters, so it's abbreviated. And the message even rhymes, happy B-Day to you in 2022. So this message we want to create from random samples of letters. So we start slowly. We just sample from the letters of the alphabet. You see here, letters is a built-in R vector that holds the letters of the alphabet, so we don't have to type them out. We use base R's sample function to draw from that. Size 5 means that we want to draw 5 letters, and we do that with replacement, so the same letter can appear multiple times. So this is the key function, and then we just paste these individual letters together to form one word. And I don't know if all of you are familiar with this symbol here at the end of the line. For about a year or so now, I think since our version 4.1, we have base R's pipe operator. So if you know the tidyverse, you maybe know tidyverse pipe operator. I put it in the chat, the percentage, larger percentage, the Magritte pipe that has become so popular in R. And now since R4.1, we have this base R pipe operator that I use here to pass on the result of this line of code to the next line of code. So paste takes this sample of random letters and collapses them without blanks to form one word of 5 letters. Right, so I hope this code makes sense to you. And then maybe you know that computers don't create real random numbers or samples. They're not really random, but you always get the same results when you have the same starting point. And you can fix the starting point by using the setSeed function. So here I just used the seed 1 and we get this word. It doesn't make sense in any of the languages that I know. I put it in Google Translate, and I don't know if any of you can confirm or contradict me. Apparently, in Arabian, it means answer. So I found this a nice coincidence. But yeah, it's not a sensible word in any of the languages that I know. I see a question in the chat. If this is similar to the Magritte pipe, yes, it is. It's not 100% identical. I think in this version, you can't use the dot as you can use in tidyverse to denote the data object that you refer to, but it works for simple use cases. It works just like the Magritte or tidyverse pipe that you're familiar with. So you can use that as well, and you have no package dependencies. So here, we're not using the purrr package on this slide yet. We'll get to the purrr package, of course, but this is pure base R code. So without loading any packages, you can use a pipe operator now. Right, and then we use exactly the same code, only with a different seed, set seed 2. Exactly the same code, and now, of course, we get a different result, different letters. And now this doesn't make sense in any of the languages that I know. Again, I don't know if you know any languages where this is an actual word. For me, it isn't. Right. But if we want to be magicians, we should know some magic seeds. You saw that in the course material, in the workshop material, there's this data set, magic numbers. So we can pull out some magic seeds and see what they produce. So here I have this seed, 1.9 million and some details, and we use the same code as before. I also added a function from the string R package, string to title, to start the word with a capital letter. We sampled from small letters. There's also letters in capital letters, an R vector with capital letters, but here we only produce small letters. So I use this stir to title function to make the first letter a capital letter. And so we have this seed, 1.9 million and some details, and here another seed, 942,000 and some details. And now we get two words that are actual words in English, and something that maybe data analysts often say or hope for, more data. We need more data in many cases to create better models. So here we have random seeds to create these words, more data. A little anecdote about R. Some time ago, I think around R version 3.5, something was changed in the random number generator, because apparently it didn't behave as desired in some circumstances. So there was a fix to the random number generator. So that means when you use this code on an older R version, I think before 3.5, you may get a different result. But nowadays, if you follow this code, you should get the same result as me using the same seeds. Okay, so a question to you now, looking at this code, is if you find this code elegant. We have just created two words here, more data, but what about if we created longer messages? You saw that the first message that we created and that we want to get back to is happy B-Day to you in 2022. So that's more words. What if we wanted to create more words? We would need one block of code like this for each word. So we would have a lot of repetition. For the next word, we would have to use the same code again and only exchange the seed. So that's not very elegant. So how can we make this code more elegant? Maybe you can think about this for a moment. So we talk about functional programming. So the idea, of course, is to write a function. So maybe you can think about for a moment what the function would look like. We can basically wrap this code inside a function. So let's see what it looks like. We'll see that in a moment. First, one slide about motivation, when to write a function. I don't know if you know this book, R for Data Science. I think it's quite popular, written by Gary Grolemont and Hadley Wickham. And the nice thing is, of course, you can buy it, but you can also read it online for free. So most of the books, or maybe all of the books that are published by the Tidyverse team, our studio team, are available online for free. So R for Data Science is no exception. You can read that, and you'll find this quote in a chapter about functions. So when is a good moment to write a function? Whenever you find yourself copying and pasting code more than once or twice, you find yourself reusing the same code and copy and pasting it, then thank you, Billy Kiesel, for the link. Yes, that's the book, the online version of the book. So that's a nice resource to get into data analysis. It shows the full cycle of data analysis, from reading in data and data preparation to creating reports. Okay, so it's a good time to write a function. Now, if we want to create more words like this, we would reuse the code, so we put it in a function. What could the function look like? Well, we take the code and just wrap it in a function. So we assign this to a function. I call it magic message, and it has one parameter, the seed. we want to pass it a random seed to create words from that. So it's almost the same code like before, only here this line takes the seed as the function argument and not the actual hard-coded number. Right, so how can we apply this function? Well, we can use it straightforward, I think. We call the function and we pass it a seed, and we're using the same seeds that we saw on the previous slide, the 1.9 million and something, and the 942,000 and something. And of course, no surprise, we get the same result, more data. But now, if we want to create more words, we still have to use one function call or one line of code for each word that we create. It's less repetition than before. The code is more elegant now, but we can do even better. We want to create a whole sentence or several words at least from one function call and not only one word from one function call. So how can we achieve that? Maybe you've seen functions that can do that. And we can see one more function from base R before we get into the purrr package. So I don't know, some of you maybe are working in the script, so you see how it goes. So you can think about it for a moment, but we'll reveal the secret. So we can use lapply, for example. And now the difference is that I don't call the magic message function with just one random seed, but with a vector of seeds. So I first create this vector seeds, I pass it the two seeds that we've used before, and then I use lapply, and I get this result back. Now a prize question for you, and you can answer in the chat if you like. Which data type do we get back? Which type of object is that? What do we see here in the console when you work interactively in R, or what you see on the slide here? Which object type is it? Okay, I see several answers, a list, that's right. So it looks a bit different than before. Before we got a vector here, and now we get a list. So how can we change this function so that it does not return a list, but a vector instead? A list is not always very comfortable to work with. You see this notation with the double square brackets and then the single square bracket, so it looks a bit awkward maybe, and it's not as practical to work with. So how could we change the code so that we don't get a list back but a vector? I'll show you two solutions. One is we can use sapply. Sapply is very similar to lapply, but the S in sapply stands for simplify. So it simplifies the result, and here it sees this list can easily be transformed to a vector, so we get a vector back. Prize question, and I accept answers in the chat. Let's see if anyone has an idea. Are you happy using sapply, or has any of you made maybe any bad experiences with sapply, or is there a reason maybe not to use sapply? What do you think? And if not everybody is talking at the same time, I think maybe now it's a good moment. If anybody would like to speak out, that's also possible. Not serve our purpose, okay? Yeah, good answer. It returns a vector in this case, so it's not too bad. The danger in sapply in programming is it simplifies the object, but you don't know in advance when you pass it different vectors or different data, you don't know which level of simplifying is possible. So you may get different data types back. So you can create examples where sometimes you get a matrix back, sometimes you get a vector back, or sometimes if no simplifying is possible, you may get a list back. So we can say sapply is not type stable. So it's nice in interactive work, but it can be a bit dangerous in programming because you don't know in advance which data type you get back. Another option that we could use here is to use lapply and then use the unlist function, which also turns the list to a vector in this case. So we can achieve what we want here using plain base R, but now we want to get to the purrr package and see what the purrr package can do for us. So one of the benefits of using the purrr package is we have these map functions, and the key function map is just like lapply, it always returns a list, but we have several variants of map that can return different data types. And the nice thing here, the benefit is that the data type that we get back is part of the function name. So just when we read code, even without executing it, we always know what the return data type will be. So for example, we have a map character function that always returns a character vector. If it's not possible to return a character vector, it will throw an error, but it will never return anything different than a character vector. And then there are a couple of other variants. I have a later slide with a more detailed overview, but for now it's fine to know that we have different variants. Map integer, for example, map double for numeric numbers with decimals, map logical for true false values, and so on. There's also map data frame. You can build up data frames row-wise or column-wise, so there are functions for that. You'll see that on a later overview slide. For now, we will just stick with map character because we want a character vector back or a magic message. Right, so I hope you could follow me so far. Please always feel free to interrupt me or to ask questions in the chat if you like. So let's see how we can apply the purrr package. So here I contrast lapply to map character. If we just had used map without the underscore character, we would get a list back as well. But if we use map character, we get this character vector back. And this is safer to use than sapply because we can be sure it will always be a character vector. Right, and the code I think is quite concise. It's just one line of code. We have a vector of seeds and the function that we created before magic message. And that's enough to execute this function several times and to apply it to each element of the seeds vector. In this case, it's only 2 to keep it simple, but it could be a longer vector as well, of course. Right. So far, for a quick introduction to the first purrr function, of course, we will take it a bit further. I would like to add a little bit of information for you to orient in the script. If you follow along in the script, something I forgot to mention before, I don't know if you're all aware that you can structure your scripts. And you see that I have these comments with 4 hashes at the start and at the back. I don't know if you have seen that before or used it before. Other comments just have 1 hash. So these 4 hashes at the start and at the end of a comment mark it as a headline or an element of the script that you can navigate to. And there are 2 ways how you can use that for navigation. You see that there's 1 line between the script and the console, and it has these double arrows. So you can click on that, and then you see the outline of the script is shown there, and you can navigate to it. So when you only want to execute part of the code maybe, and you follow my presentation, I described it just as it is in the presentation. So you can jump here to different parts of the script to see where the code is and what it does. So you can use that. The second option is here at the top of the script, you also have this line where you can run lines of code and so on. And on the right-hand side, you have this symbol that is a bit similar to Microsoft Word. You can click on that, and then the outline is shown here and stays there if you like that. So I don't use that often because I want the whole width of the screen that is possible for the script, for many cases, for long comments, but so I prefer this. But if you like this, to see the structure permanently, you can use this option in RStudio to navigate your script. And you see that it's not only the headlines that I mark that are shown here, but all the function definitions are also shown. And when I use this option, it also shows me the function arguments. So we use this magic message function, but I redefine it several times in the course of the presentation. So you see what the function arguments are. We start out with just 1 argument with a seed, and later we will build it up and we have 2 and 3 arguments. So I will go through that slowly. Right, so this was a little extra about how to navigate your scripts. We go back to the presentation. And the last function we saw was the map character function. And we compared that to the lapply function. We see with lapply, we can iterate over a vector of seeds and apply a function to each element. And we can do the same with map character, but with map character, we get a character vector back and not a list. Okay, so far maybe you've noticed that our function can only return 4-letter words. There's the song and the saying, love is just a 4-letter word. So now we can only produce 4-letter words. So our magic message function is not very flexible. And when this code that you see here is the same that we saw before, I just repeated it. So you see that the number 4 is hard-coded in the function size 4. What if we want to generate words of different length? We need to make our function more flexible. And that's what we'll do now. So again, I define the magic message function, but now I extend it a little bit, and you see that it now has 2 function arguments, the seed we had before, and now the additional argument is the word length. And then in the function body, where it says size, we don't say size equals 4 anymore, but we pass it this function argument size equals word length. So that's the second version of our magic message function. I hope this code is still easy for you to follow. Let me know if you have any questions. So now we can apply this function, but we can't use lapply anymore, at least not so easily, and not map character anymore, because these functions just take 1 function argument. And now we have 2 function arguments, seed and word length. So we need a way of iterating over 2 vectors. And the function that we can use for that purpose is called map2, the 2 indicating that we iterate over 2 vectors. And the function arguments are now .x and .y. The dot is used in the tidyverse so that it's less likely to confuse these function arguments with objects that you may have in your global environment. So maybe you have a vector x and a vector y. So here you see that these are not objects in the global environment, but function parameters. So we have .x and .y for the 2 vectors, and .f stands for the function that we want to pass. So here's an example. Maybe remember, okay, there's a question in the chat. Paste collapse equals doubles quotes. You can try out the function and leave out this line of code, and you will see that you get 5 separate letters and not joined together in one word. So we paste them together and we collapse them without blanks and join them to one word. That's what the paste line does. Right. Okay, so we extended our function to take 2 arguments, seeds and word length, and to apply that, I created a simple example. We have 2 seeds. Now they're different seeds than before, and you see that we are starting already to build up the message that I showed you in the beginning, Happy B-Day. It's not the full message yet. The numbers are missing. We'll get to that, but at least we have the start of this message now, Happy B-Day. And you see that we have different word length, 5 letters and 4 letters, and this is signified in this vector word length. And we have these 2 seeds, and we apply these seeds and these word lengths using the map2 character function now. And passing it the 2 vectors, so seeds corresponds to this .x argument, word length corresponds to the .y argument, and magic message is the function .f. Right, so we're getting there, we're building up, but we're not quite there yet. So far, we have passed 2 vectors to our function. This is a nice extension already and something I haven't seen with lapply yet. So the map2 character function, but later we will use 3 vectors even to iterate over. And now you could think we have a map function, we have a map2 function. So you may expect to see a map3 function, but no map3 function exists in the purrr package. So we need to find a different way. That could get complicated. You could even think of functions that take more arguments. So the purrr package creators and maintainers would have to create a lot of functions, map4, map5, and so on. But this doesn't exist. It stops with map2, and then we need a different way. So we need to extend our function once more and make it even more flexible. So I hope you remember the original message, Happy B-Day to you in 2022. And we have this year 2022 that is not possible with the current state of our function because we always draw from the letters of the alphabet and the numbers are not part of this built-in vector letters. So let's make our function even more flexible, extend it one more time. So we do that here on the right-hand side. It's still called magic message, but now it takes 3 arguments. So the seed and the word length we already had before, and the new argument that we added now is called choices. So what to sample from. And you see that this argument choices is used here in the sample function. The first argument of the sample function is what to sample from, and we pass it the function argument choices. And where before we had hard-coded letters to always sample from the letters of the alphabet. Right, so I hope this function still makes sense to you. We built it up slowly, so I hope you could follow. And you see that now we can create a magic message more flexibly. We can provide the seed, we can provide what to sample from, and we can provide the length of the word. So, but we don't know yet how to apply this function. We saw the map2 function before, but now we have 3 arguments, and I said there's no map3 function. So we need a corresponding map function that is able to iterate over 3 vectors at the same time. And this function is called pmap, where p is flexible and doesn't limit the function to a specific number of vectors, but instead a different approach was chosen. There's just one argument, .l, and .l stands for a list. So we can pass it a list of vectors and a function .f, and the 3 dots we are not using today, they can be used to pass on further arguments to functions. For example, when you use the mean function, you can pass on arguments like na.rm equals true to remove missing values. So things like that can be passed on using the 3 dots, but today we're not using the 3 dots, we're just using the list of vectors and the function. So we're getting there. I'm using more magic seeds here. So we have different seeds now, we have different word lengths, and we have choices. Maybe this is not so obvious to see at first glance. Choices is a list, and I pass it the letters of the alphabet 5 times for the first 5 words, and for the last element of the list, I pass the digits from 0 to 9 so that we can also create a number, so to say, of length 4 digits, numbers between 0 and 9. So let's use these seeds and these word lengths and these choices to create our message. Okay, there's a question in the chat. How do you define the seed vector? There are 2 answers to that. I think the simple answer is I just assign it the numbers, but maybe you mean where do I get the seeds from? I have also created a video. I have a YouTube channel. It's linked in the slides. So you see here my YouTube channel, and I have a video about this idea that I show you today there as well. And somebody asked me how I get to know the seeds. So they thought I had some deep intuition or some deep insider knowledge about R and the random function, like looking at the code and knowing which seeds will work. Unfortunately, this is not the case. I'm not this type of magician, and I can't come up just like this with random seeds. So the answer is it's brute force, actually. So I wrote a function that tries out all kinds of different seeds to find certain words, and it's a lot of computing power and time that goes into finding these seeds. So there's no like real insider magic knowledge involved, but a lot of calculation and trial and error, you could say. But so I have these seeds, and for you to play around, you have this data set magic numbers with some seeds that you can use to create your own messages. Okay, I hope that answered the question, Naimur. So this is how we can apply these 3 vectors to our magic message function. We're using the pmap function, and analogous to before, there's a pmap underscore character function to return a character vector, and we pass it a list of vectors with the 3 vectors, seeds, choices, and word lengths bundled in the list, so that they correspond to this first argument of the pmap function .l. and then we just pass it the magic message function, and then this code iterates over all 3 vectors at the same time to use this magic message function and to create our message. And the cat function removes the quotation marks from the output. So here we get this message that you saw on the first slide. Happy B-Day to you in 2022. Created from this code, from quasi-random samples, we could say, of letters and numbers. So you could write loops, of course, or write a lot more code to achieve the same thing. The code on the right-hand side of the slide is exactly the same, just I added comments to make it more obvious. So indicating which part of the code corresponds to which part of the arguments of the PMAP function. A list of vectors, a function, and finally the cat function to remove the quotes around each word. Right, so this is basically the first part of today's presentation. I have one last slide that I want to show you, and then maybe we can open up a little bit for discussion and questions, or also have a short break and see. The last thing I want to mention before we go into a discussion is, I don't know if you're amazed by this. Maybe you think, okay, wow, looks nice. But the question could be, how is this useful in a real-world application? Probably in your day-to-day data analysis, you won't spend too much time on creating magic messages. So the question could come up, where in practice can I use this coding technique? Maybe before I show you an answer, I can ask this and see what you can come up with. Has any of you used a technique like this? Or have you got ideas where to apply this technique? Any scenarios where you would like to iterate over more than one vector at the same time? Have you had such a use case before? Maybe you wrote for loops, or how did you do that? Or can you imagine a use case for this? You're welcome to paste in the chat. And also, I don't think everybody will talk at the same time. So if you like, you can also speak out. Doesn't seem to be the case. No ideas for use cases? Yeah, Babatunde, you're welcome to speak.
All right. Thanks for the wonderful presentation so far. So I think in real-world application would be a case whereby I want to use rvest for data scraping, for instance, and I have this pignation on the website that has page 1, page 2, or so. Then I can have a vector of these page numbers and my nice and tidy rvest. Then I can just use purrr now to do that.
Well, thank you. That sounds like a very cool use case. I must admit, I haven't done much web scraping yet, just a very small example. So that sounds very intriguing. So if you have any code that you'd like to show, that would be very interesting. Or maybe, I don't know, if you want to do a presentation sometime about web scraping. I think it's a very rewarding and interesting and challenging topic. So yes, I think that's a good scenario where this will work well. Okay, some comments in the chat. Thank you for that. Random state 1 of 3, yes. Replacement of for loops and to make code look cleaner. Yes, I definitely agree. Naimul says, give a practical example. One example I prepared is when you want to save subsets of your data. Let's say you have a huge data set with a lot of categories, and somebody, maybe a stakeholder or sponsor of your project or whoever, needs subsets of your data for certain categories. Maybe you have a categorical variable and a lot of categories in there, and for each category you need a separate subset that you need to save in a separate file, maybe in a CSV file. So you could have a vector of file names and a vector of categories, and then elegantly loop through that with a map function to create these files without writing a for loop. So we can look at a coding example that I have prepared that does just that. I have a simple example with only a few categories, but once you have the technique, I think it's very easy to extend to larger examples with more categories or larger data. Okay, Bilkis also wrote in the chat, use case where you want to manipulate more than one column of the same data type at the same time. Yes, that also sounds like a good use case. Right. Maybe a short feedback how you found this example. Was it okay to follow, or did I raise a lot of question marks in your heads? Is anything about the code unclear at this point? Thank you, Abraham, for this comment. In PAM clustering, yes, okay. It sounds also like an advanced use case, sounds very good. So you've used it already. Did you use the purrr package for that, or did you use a different technique? I'll apply maybe, or as apply. Any questions about the code up to this point? I don't know, you will probably have different backgrounds. Not all of you will have the same level of experience in R, I guess. So could you follow the code so far, or any questions about the code at this point? Doesn't seem to be the case. Okay. So I can give you a short outlook. We have 3 more scripts that I can show you. So the one is the CSV file example, where we iterate over a vector of file names and a vector of categories to create separate CSV files. So I think we'll go through that. And I also have one where we create different plots with a map function, so that we have just one line of code for several plots for several subgroups, where we are not using facets that you may know from ggplot2, but really create separate plots that you may need in separate places. So we could look at that as well, and have a couple of slides with some more background about the purrr package that I'd like to show you. Maybe, I don't know, it was quite intense, maybe for some of you, I think. I'd like to have a short break, maybe a few minutes, and then at least I need a very short break, and then we can do the second part and look at more coding examples and maybe some more background about the purrr package. Shall we do that? Maybe 5 minutes, is that enough? And then come back? Okay.
Sure, I think 5 minutes will be okay. I think we'll hold on for that. So please, while we're waiting for Wolf to join us back, so I want us to look at the code again. You can have it from the R Studio Cloud, or you can download from the link shared earlier. So let me just share the links again. Okay, sorry, I'll have to copy this and see. So you can have it. I've shared the link again in the chat. And also for the slides, let me copy this out again. So we have that in the chat. So kindly go, if you don't have access to it yet, you just need to, it's a free account that you can create on our Studio Cloud. So you don't need to make any payment. So you can just download the code there and the slides. Look through. If you have any question, please just feel free to get it written down. This is supposed to be a workshop, and he has actually prepared so well for the program. So I believe we'll all benefit if we take a break, take a glass of water on the side, and then we'll come back into the workshop. So thank you so much for your time, and we really appreciate your support. So we're almost 2 minutes into it, so we're almost there. So thank you so much for waiting and be patient with us.
I'm
So
back.
I would like to use this, oh, sorry, Wolf, let me use this opportunity to appreciate our co-organizers, Fidelis Obani, Stephen Abubakar, we have Mabel, we have so many people. Okay, I also want to appreciate Hadia is from the Our Ladies Tunisia. So I really appreciate your support, and most of our members here, I can see them, they showed up early. We appreciate all of you. We really appreciate you. So thank you so much. Abiodun, thank you so much. I can see you all there. So Nuruddin, so many people, I can't continue. We have a lot of people in here. So we're really appreciative of your presence. So many participants from all over the world. So thank you so much for joining us so far. So thank you so much. So I'll give you the chance now to take over, Wolf, if you're ready.
Yes, I'm ready. Thank you
Okay.
also so much.
Okay. Thank you.
So I'm back. So this would be a good opportunity, I think, to ask any questions about the code that you were afraid to ask before during the flow, during the presentation. So now's a good opportunity if you have any questions about this code. Maybe I should show the last slide again with the last example that we slowly built up. I hope you could follow and you have the code to try it out for yourself and maybe vary. For example, you can use different seeds and create different messages if you like, and play around with the different versions of the magic message function to see how it applies. So I go back to the code. So at the end of the script that I provided, I encourage you to try it out for yourself. So I already admitted that I don't have this deep intuition for magic numbers. So you can check out this data set, magic numbers. I showed here, it's got 75 entries. Maybe one word of explanation, you see some NA values there. This is not a mistake, but by design, I indicated that for these words, I haven't found any magic seeds, and I think there aren't any magic seeds for these words, and because there's actually a limit on the number that you can use for magic seeds. There's an upper limit, and if you go beyond that, then you get an error message and you can't increase the seeds. So there's a limited number of combinations that you can try out, and of course, each letter, there's 26 letters in the alphabet, so it's like an exponential growth. For each letter that you add for longer words, it becomes less and less likely to find a seed that generates exactly this word. So for example, unfortunately for the word beautiful, there's no magic seed, at least not according to my trials. And also like cruncher, I wanted to make a message with number crunches. Or favorite is too long, like favorite programming language or something like this. I didn't find any magic seeds. Programming is also too long. Artistry, unfortunately, I don't know if you're into artistry, like creating beautiful plots that don't represent data, but that are works of art. Did you try letters with umlauts? No, I didn't. I stuck to English. I started very slowly with German, but I haven't done much work on that. I don't think I have the umlauts in that, no. Also, your tidyverse, unfortunately, is too long. But there are some nice words, so if you like to play with this, there are, I think, a number of messages that you can come up with. Christmas, for example, Xmas at least. So the last example that I have in the code from presentation, so where I encourage you to try out, I use the second last version of the magic message function without the numbers, just letters, but with the two arguments, seed and word length, and trying some different seeds and different word length. And it's always dangerous when I don't execute the whole code. So using these seeds here, you get the message, are you ready? And something that you see very often, forgive me for doing that as well, in the R language, playing with the letter R. So are you ready? But just with R, one letter. So here, not using the pmap function, but just the map2 character function, because I use the version of the function with two arguments and leaving the choices fixed as letters. Right, maybe so much for this example. There don't seem to be any questions about that. You're still free to ask more questions if you like. So I also encourage you to try it out for yourself and play a little bit with it, but to not bore you too much with these magic messages and maybe get you thinking that it's not very practical, it's just for playing. Maybe it's a good moment to switch to a more practical use case with the subsets of data that we want to save. So this is the CSV file example, and maybe we just go through the code together, and you can have a look. It's not now part of the presentation. I have a few more slides that I'll show you later, but maybe we just do that here in the code. And of course, again, you're welcome to ask questions. I zoom in a little bit more to make the code more readable. And I think we can take the time. We have a lot of time today, I think. So it's for you. Don't feel embarrassed to ask. I think there are no bad questions. The worst thing that can happen is that I give a bad answer, but any question is always welcome. So yeah, if you like, we can look at the CSV file example. What I want to do is, I use a very simple example with a built-in data set so that you don't have to download data from anywhere. So if you have the tidyverse package available, the diamonds data set is part of ggplot2. I don't know if you've seen the diamonds data set before. You know the saying, maybe diamonds are a girl's best friend. So always a good idea for a present if you can afford it. So we can work with the diamonds data set that you should be able to access directly once you have the tidyverse loaded. And the idea is to create one subset of the data for each cut of the diamonds. So let's have a look. I clean up my environment to make it ready for this example. So I create a vector that contains the cuts, and I use the levels of this cut variable from the diamonds data set. So we can look at the cuts. So you see there are 5 cuts: fair, good, very good, premium, and ideal. So again, this is quite a simple example to illustrate the idea. I didn't want to make it too complicated, but I think you can easily extend that to more complex situations in real world examples, maybe when you have, I don't know, data sets with hundreds of categories and you need separate data sets for each category. It can become quite cumbersome to filter for each category separately. So we will do that in a more automated way. I also create a vector of file names, and you can see if this code makes sense to you. Maybe you haven't seen all the commands that I use here. So basically, I just use the cuts. I could also use this vector of cuts now, but I wanted to do it from scratch from the diamonds data set. So I pull the cut variable. This turns it to a vector. The pull function is like select, but it just returns a vector. Then I use the levels of the vector, so it's the same that we did here. And then I replace the blanks with an underscore, and then I create the vector of file names from that using the prefix diamonds underscore cut underscore, then the actual cut, and then the file type .csv. So I execute this code, I run these couple of lines of code, and you see I get a vector of file names. We can look at it in the console. And we have diamonds cut fair.csv, diamonds cut good.csv, and so on for the other cuts. Very good, premium, and ideal, all as file names. The actual files do not exist yet. It's just a vector of file names that we want to create, but we have not created the files themselves yet. Are you with me so far? Any questions about this code, about what we did so far or what we want to do? I hope the idea is clear. So the files themselves are not there yet. We just have this vector of file names. Maybe we can take a moment to look at the diamonds data set if you're not familiar with it. So I look at the structure of the diamonds data set. So it's quite simple in terms of the numbers of variables, just some attributes of diamonds, but you see it's quite large compared to other toy examples. We see a lot of examples in R with the empty cars data set and so on. So here it's not as trivial. It's got 53,940 diamonds in that data set, so it's not too small. Okay, so how could we create separate data sets for each cut? And now for this example, I created a classic for loop to show you the difference in the contrast and how it is more elegant to avoid the loop and to use LPI or map functions. So the classic for loop is here. I have this vector of cuts that I generated before that just contains the 5 cuts from fair over good to premium and so on, ideal. And I use that to loop over the elements. For my cut is a custom name that I chose in cuts. This is the vector that we generated before and that you see in the global environment. Then for each iteration of the loop, I filter the data set. So I use the filter function from dplyr and filter for the cut. For the cut here, my cut that corresponds to the iteration of the loop. Next to the data set, I also create the file name, going from my cut, which just contains the cut, to the actual file name like we did before, pasting together the file name, replacing the blank with an underscore, and then creating this prefix, diamonds underscore cut underscore, pasting the actual cut, and then the file ending .csv. And then we can use the write CSV function from the readout package, which is part of the tidyverse, to actually save that file. So I hope this code makes sense. Let's try out if it works. I run this block of code, and you see that in the bottom right in my RStudio files pane, you see the 5 files. They are actually there. Diamonds underscore cut fair.csv, diamonds cut good.csv, and so on. And you see different file sizes, so it looks good. Apparently it worked. So this is a classic way that you see sometimes in R. People who come from other programming languages often think in terms of loops. So I don't know if you're C programmer, maybe you tend to write loops. So that's perfectly fine. It works in R, but in some use cases, loops are a bit slow in R. In our case here, with just 5 files, the speed is not the criterion, but maybe the code can be more elegant than this. So let's see how we can change this code. I can delete the files again using the unlink function to show you that the other approaches also create the files again. So unlink file names deletes the files. You see in the bottom right in the files pane, the files are gone. And now the first step, as before, is to write a function again. So I call it myCSV, and it takes one input, the cut, the actual cut of the diamonds. So there's no for loop here. It's just a function, but it's the same code basically as before. We create a subset of the data called data, filtering by the actual cut, and then we create the file name like before from the cut using the prefix diamonds cut and the suffix, the file type .csv. So I define the function. Note that when I run this code here, it only defines the function, but it doesn't save the files yet. So you see in the global environment on the right-hand side, I now have this function, myCSV1, but no files have been saved yet. I do the saving here. I can for one last time, use a for loop again, but this time instead of having this long block of code, it's a bit more elegant now because the function is separate and I can just pass the function here and the function argument. So this code is shorter now, but it's still a for loop. So let's run this. And it looks good, it works. You see in the bottom right in the files pane, the 5 CSV files appear again. Okay, but this is still a for loop and we want to avoid the loop. We want to be more elegant than that and iterate with one R command without writing the loop ourselves. It's a famous quote. I don't know, I think it was Jenny Bryan. Somebody has to write a loop, but it doesn't have to be you. So we can use functions that loop through elements internally without us writing the function. So what we did so far was to filter for the data and to build up the file name in each iteration. The file name was generated separately for each iteration. And now we want to use just a vector of file names that we actually have already created. You see it in my global environment, this vector of file names is already there. So now the function even becomes simpler. It just filters the data, but the file name can be used as a vector and doesn't have to be built up inside the function. But now the function has 2 arguments, of course, the cut that we want to use and the file name as a vector, as a function argument. So this is what the second version of our function looks like, mycsv2, taking the cut as an argument and the file name, filtering the data, and then just reading, using the reader function, writing the CSV file out. So we can do that. And now the application is very similar to what we did before. We're using the purrr package now, finally, for the first time in this script. And we're using the map2 function because we want to map over 2 vectors simultaneously, the cuts and the file names, and write out the CSV files. So after having defined the function, the actual code to create all the files is just 1 line of our code. So I think that's quite concise and quite elegant. So I'm executing this, and there should be no surprise. Looking in the bottom right pane, you see the 5 CSV files appearing again. I had deleted them before, so now they're back. So we have saved the files again, like before. But now the big question to you is if you noticed what happened in the console and if you can explain what happened there and why it happened. What happened in the console while I ran this map2 function? Anyone? Feel free to speak or to write in the chat. The files were saved, so the code worked as expected, we could say. Yes, Arup writes, it has created a list. Yes. And what is that list? Can you be? It's slicing as per filtration criteria. Yes. Okay, so you're right. You're both right. You see in this notation with the double square brackets, we got a list back. And we said that lapply and the basic map functions, I didn't use map character here. I didn't want a character vector back, of course. I just used the map function, map2 in this case. It's map2, or like map, returns a list. So we get these data sets that we created also back as a list and not only stored on disk as CSV files. And you see the first element of the list is the first subset of the data, cut, fair. The second element of the list corresponds to the second cut, good, and so on. It only prints out the first 10 rows of the data, but you see here at the bottom, there are a lot more rows. Thousands of rows for each subset of data. Cut, very good. Cut, premium. Cut, ideal. So we get a sliced list. Babatunde is raising a hand. Please feel free to speak.
Yeah. Hello. So I'm just thinking, I guess using map2, there's a need for it to return a value each time we use map2. I'm just guessing. Is there any other function within the purrr library that we can use that will not necessarily needs to output
Perfect question, and that's exactly what I wanted to get to. Yes, there is. So we'll use walk instead of map. I think it needs a little bit of explanation. We can talk about functions and return values and so-called side effects. So in many cases, we call a function because we are interested in the return value. For example, when we calculate something, we want the return value. We want the actual result. When we create a data set, we want the return value. We want the data set. In the previous example, in the first part of the presentation, we created this magic message, and that was what we wanted. The return value of the function was the message, and we were perfectly happy. In this case, we actually don't want the return value. The return value is the list that we see in the console, but we're not really interested in that. We didn't use our function mycsv2 to create a data set to be displayed in the console, but we used the function actually to save something to disk. And we can call this a side effect. It's not the actual return value, but it's a side effect of the function that something is stored on disk. So for these cases, when we call functions just for side effects, we can use the walk function. We can replace map with walk, and then we get a silent function call, we could say. No value is returned, but the side effect still happens. The files are still saved, but we get no output in the console. So that was the perfect question that you asked. It was exactly the right thing, what we should wonder here and what we can solve here. So let me show this. I use the unlink function again. So keep an eye on the files pane. You see the 5 CSV files. I use the unlink function. So the 5 CSV files are deleted. They're gone. And now I use the walk2 function. So walk is like a family of functions, just like map. It has walk, walk2, walk character, and so on. All the variants that you know from the map function that I showed you before in the first part can also be accessed as walk variants. So in this case, we use walk2. The rest of the code is exactly the same. It's from the purrr package. It takes 2 vectors, cuts, and file names, and it calls this function that we defined before, mycsv2, that stores these CSV files. So let's do that. And you see in the bottom right in the files pane, the files are saved again. The 5 files are there again, corresponding to the 5 cuts. But you see also in the console, you see the last command that was executed, but there's no output. So we have no list output. We don't have this double square bracket notation, not even an empty list, no output at all. So walk is a nice example here for a function that we call purely for its side effects and not for the actual return value. Right. That was basically the second example. So we're quite quick today. I think we have lots of time for discussion. So my first question to you now is if this code makes sense to you, if you could follow along, or if there are any questions about this code, what we did. And if you like, the second question is, do you find this a more practical use case? Can you connect to that? We had some fine examples of use cases before, but some of you maybe thought, I don't know, with these magic messages, if I will ever use that. Of course, here we kept it a bit simpler. We didn't use the pmap function. We didn't iterate over more than 2 vectors, just 2 vectors. So you don't always need the pmap function. But I think it's something that you will find hard to do in other ways in that simplicity. Okay, there's a good question in the chat by Naimul. What is the difference between map function and walk function? Okay, basically you can say map, like lapply, always returns a list when you are interested in the return value of the function. And walk does not return a list or any other object type. It runs silently, you could say. So in this case, we didn't want the return value, but we wanted the side effect, which is saving files to disk. But we get no return value in the console. Or if we made an assignment, we can try that. I call it test now. I make an assignment. Oh, it actually returns the it returns the cuts, but it doesn't return the data sets. So it returns just the input, but it doesn't return what was actually calculated and processed. So we can say it's silent. And when we run this without assignment, it does not display the return value in the console. The console stays empty, and we can focus on what actually happens, which is a change in our folder on disk. So I hope this made it a bit clearer what the difference between map and walk is. I can run map again for comparison. Line 74 in the script, map 2, and you see a lot of output in the console. We get all the filtered data sets back as a list, with each entry of the list being one subset of the data. So map returns this list, and walk silently just returns the input but doesn't display it in the console. Right, so I hope this was a bit more practical, a bit closer to your use cases. And now I hope more of you can see how you can make use of purrr functions in practical projects. Maybe another question. I talked about side effects, and I said saving files to disk is a side effect. Can any of you think of other side effects of functions that we may be interested in? Or are you familiar? Can you relate to this idea of distinguishing between return values and side effects? Does that make sense to you? And have you got ideas of other side effects of functions? While you think about side effects, maybe for those of you who are very keen on programming and trying something out, if you like, you can adapt this example that we saw here to a different data set. You can use a built-in data set. I don't know if you can use empty cars, but of course you can use any other data set, maybe of any of your favorite packages. The mass package has some data sets for machine learning, like the Boston data set, and you can use that to save different files for different subgroups of the data. For example, in the empty cars data set, you could use the number of cylinders. There are several cars for each number of cylinders, and you could create a separate data set for each of these and save them to disk. It's still a simple example. Maybe if you have a larger data set, you can use a different example, maybe from your own work, to save subsets of data with one line of code, with one call to a purrr function. But of course, you need also a custom function that you pass to walk or walk to. Okay, meanwhile, there were a few more answers in the chat about what side effects of functions could be. Downloading a file, yes, I think that's a good example. Any persistent changes are side effects. Babatundi, yes, that's also a good answer. Have you got any idea, like what could that be? What have you got in mind for persistent changes? Examples, maybe? And Victor says plotting. Yes, that's also a very good example, something that I thought of too. And I have another script actually prepared that shows plotting as a side effect. So if you like to see that, we can try that out as well. That's one of the options for the later part of this session. Right. There seem to be no questions at the moment. Maybe a note about speed. Maybe you've heard that when you hear talks or read about R, it is often said that loops are slow in R, or loops have a bad reputation in R, and you should avoid loops. I wouldn't be too harsh on that. Of course, in many cases, now we learned about map functions and walk functions and apply and sapply and so on. Code like this is more R-like, you could say. It's more elegant, it's more concise. But you can't always avoid loops, and it's also not true that loops are always slower. I found it interesting here. I made a speed comparison, and in this case, the overhead for the loop is very low, we only have very few files. There are only 5 files that are stored, so there are only 5 iterations through the loop. So the loop is not costly, and the map to and walk to functions are actually slower in this use case. So I commented out this code. I don't know if you have the bench package installed. There's also the micro bench package that you can use. Bench is a bit newer, but in this use case on my machine, the map to and walk to functions was slower and the loop was actually faster. So it's not always the case that loops are very slow. It's more likely when you have more iterations, then each iteration of the loop is costly, and then the loops tend to be slower. Okay, there are more answers in the chat. I'm trying to keep up. Bavatone says writing to disk or updating records. So that referred to persistent changes, maybe, yeah. So yes, typical side effects, I would say yes. Okay, good answer. Noam will ask, can we do the same task by using dplyr and using filter option? Of course, you can use dplyr to filter files, and I actually use the filter function from dplyr here in my code as part of my CSV2 function. So dplyr is in action here. What I did not use dplyr for is the actual iteration part. So I don't see a dplyr function that we could use to replace the iteration part. So for the iteration, if you want to avoid purrr, or you're not too familiar with purrr, you can use lapply, but then you get the list output in the console. But I don't see how you could replace lapply or map or walk using a dplyr function. I don't know if anybody has an idea, but I don't think so. Then the purrr package would not be necessary, I think. There's actually a use case. I put it in the chat. There's a nest by function in dplyr that I didn't plan to go into much detail today. If you like, we can have a look later on. You can create subsets of the data and create nested data sets using nest by, which is a dplyr function. And then you can operate on these nested data sets, for example, to create many models for subgroups. That's quite a powerful technique. It used to require purrr a couple of years ago, and now with the introduction of dplyr's nest by, you can do it all in dplyr, and then you can use mutate to work on these separate data sets, nested data sets. Right. So this was basically the second example, the second R script that I had prepared for today. So it's 1.5 hours in. We've covered a lot of ground, and let's see what we have left. I think it's only half an hour since we had the last break, so I would go on a little bit. If you have no more questions, you're welcome to ask anytime. I think we can spend the time on your questions. It's meant for you, not for my pleasure. So this is what we did now. We saw the CSV example, and now I hope that more of you are convinced that it's not only for, I don't know, impressing people with magic messages, but also for practical use cases. So next, if you like, we could talk a little bit more generally about the purrr package and just see a bit more of the functions that it covers. If there are no questions, which doesn't seem to be the case at this moment. So I used various sources. There's an overview slide later on that shows the sources that I used. So the basic idea in purrr for these iteration functions is to map over elements of a vector or a list. So the key function is map. We have this argument .x for the vector or the list, and the argument .f for the function. And we will see here that it doesn't have to be a function. It can also be a formula or a vector. But let me first talk a little bit more about the first part, .x. So what we did today was using a vector. You can also use a list, and you can also use a data frame. I don't know if you're all aware of the fact that data frames are also lists. So I have a data set now, data, which is, I think, now a filtered version of the diamonds data set. So I can look at this data set, str with the structure. I can ask for the class, and the class is data frame. And then because it's tidyverse, it's also a tibble and a tibble df. This makes for nicer printing, for example. Maybe you know that base R's data frame is not printed so nicely. If I just type data here, or I can also use print data, you see that I don't have to scroll in the console. It just prints out the first 10 rows of the data, and it doesn't use more space than I have on the console. And then it gives me a note that there are more rows to choose from. I can change the class of the data. I can just make it a data frame. It's still the same data set. Now the class is only data frame and not tibble and not tibble df anymore. So it's not a tidyverse version of the data frame anymore. And now if I type data or print data, you see it's not printed so nicely anymore. I get 100 rows in this case and quite some scrolling. And then there's a max print option that cuts off, but still it's a lot more than what fits on the console, and I have to scroll and it's not so nice to read. So, but yeah, this means it's a data frame with some specific attributes. But there's also a type of function, I don't know if you're aware of that, that shows you the internal storage type of an object. And when I use that on the data frame, it tells me that the data set is internally stored as a list. So we can say that data frames are a special case of list, and that's why for these functions that operate on lists, we can also pass data frames as arguments. So this is about the .x argument of the map functions. It can be used on data frames. Right. And then what we did today is pass a function as the .f argument. We used the magic message function, and then we used the myCSV function to store CSV files. But we can also pass a formula. And there are several ways of writing formulas. So here you see an example. The tidyverse introduced that the tilde as a shortcut for a formula. To denote a formula. So this is short for this anonymous function notation that you see here in the first example, function x rnorm 10, x. So this applies the rnorm function to the vector 1 to 10. So 10 times we sample from the normal distribution. And a shorter form of writing this is, instead of writing base R's function x, you can also use the tilde in the tidyverse in the map functions. It doesn't work everywhere in R, but inside the tidyverse functions, you can use the tilde as a shortcut for this function x notation. Price question. This tilde was introduced by the tidyverse. The base R version is a bit longer, function x. Do you know of a shortcut in base R? Can you use base R without the tidyverse and shorten this notation with a function x? Does any of you know? Okay, Victor, very good. If I handed out certificates, you would get bonus points now. Very good answer. So this is base R notation for the anonymous function that was introduced, I think, in R 4.1, if I'm not mistaken, about a year ago or so. So now we have a shortcut in base R as well. I think it was introduced at the same time when the base R pipe was introduced. A big step in R 4.1. So one of the reasons why it's worth updating your R version. I hope you don't work with old R versions like before 4. So it was really worth updating to 4.1 and now 4.2. Right. Another topic we could talk about, and I would put that in your hands a little bit, what you are interested in most. Purrr is also quite powerful when you want to work with lists. I don't know if any of you have trouble working with nested lists or with complicated list structures. If you're lucky, you can always work with data frames or tibbles, and then data analysis is easy. The tidyverse philosophy is always tidy data in, tidy data out, so that's very convenient. a couple of years ago. You heard this anecdote in the introduction from Billy Kisu that I started R in 2007 and then I didn't want to open it again. And back then, I think people had more trouble converting between different object types. You have in base R, you have functions that want a list as an input or a matrix as an input or a data frame or a vector. And the outputs are also diverse. Some functions output lists or matrices or data frames or vectors, and it was a big chaos. And you often had to transform between different object types just to be able to use certain functions. So now the tidyverse philosophy is to always have data, tidy data as input and output. So it's much easier and the functions work together more smoothly. But sometimes you may need to work with lists. And there's an example somewhere in the description. I said the recursive package can also be required for today. So put that in the chat. It's by Jenny Bryan, I think. So she has nice examples of lists. I don't know if you're Star Wars fans. So she has lists of Star Wars movies, and the list elements are of different length. So it doesn't really fit nicely in a data frame. And it's a nested list. So the list can contain more lists as sub-elements, and that's not so comfortable to work with. And it's more comfortable using map functions than using base R functions. So if you like, there's a code example in the fourth script, so we can look at how purrr makes working with lists more comfortable than base R. Right. Maybe I just finish these few slides and then we can see where we are and maybe have a short break again and then dive in again for the next part of this session. So here you see a lot of detail on this slide. Don't go too much into the detail. The idea of this slide is just to give you a visual impression of the comparison between base R functions on the left and purrr map functions on the right-hand side. So without looking at the details, just looking at the optical impression, I hope it is quite obvious. It jumps in the eye, as we say sometimes, that the code on the right-hand side, I think, looks more neat, more tidy, more organized than the code on the left. You see, in base R, I just talked about lapply and a little bit about sapply, but there are more variants of the apply functions. You also have vapply, which is type stable because you can determine an output type. You have tapply, mapply, and eapply, and so on. I don't want to go into all the details, but you see that the parameters and the order of arguments is not consistent across functions. So we can say the grammar and the function arguments are a bit inconsistent, so it's not so easy or so convenient to switch from one function to the other. And in the map family of functions, the order of arguments and the argument names are more consistent, and it's easier to exchange one function for the other. This was an idea from Colin Fay. I don't know if you know him. He works in France for the French company ThinkR. He's quite active in the R community. He's one of the editors of the R Weekly newsletter, and he's got a blog. So he blogged about purrr. And this example is taken from his blog. Right. And this is a bit more of a detailed view of the different map functions that I mentioned at the beginning. And we have this underscore, and then we can specify the return value. So it's easy to see just from the function name which object type the function will return. So it makes the code more readable, more predictable, and people don't have to execute the code to figure out what it does. So we use the map and the map character function, and then map2 and pmap, of course. But there are other functions to return integers or doubles, logical values, or data frames. Right. Okay, feel free to ask questions anytime. I just go through 2 more slides or so. Yes. And then we're finished with the presentation and we have some more time. Maybe have a short break if you like, or have a discussion. And I have 2 more scripts that we can go through. So we can see how we spend the rest of the time then. Just one more slide with a few more. Yes, go ahead.
All right, thank you very much. I just want to ask if there's anyone that has a question. Hello, can we all hear me?
Yes.
Okay, if you have any question, you can please ask. So I'm referring to the participants now, so that we can take a short break, Mr. Wolf.
A link of map document is a question in the chat. So I understand the question correctly, like where do you find more resources about the purrr package? I said the purrr package is not so well documented, so there's only one vignette that is not very helpful, but here the last slide, or the last slide before the end slide, so to say, has some links of material that you can use to take a deeper dive. There are blog entries, there are also video presentations. You see here from Charlotte Wickham, the second link is actually a video, a recording from an RStudio conference a few years ago. So a purrr tutorial there that you can watch if you like. And there's also a GitHub page from Charlotte Wickham. There's this blog article from Colin Fair that I just mentioned. There's another question in the chat from Benson. I will answer that in a moment. Just give me a moment to finish explaining this slide. So Colin Fair has this blog article, and it's a pun, actually, a play on words. It's a French title, but the blog article is in English. So I don't know if most of you maybe speak French. Vous allez aimer avoir peur. So it's a play on words. It sounds like you will love to fear, but of course, having the purrr package in your toolbox, you will love that. Jenny Bryan has done a lot of work. I'm going from bottom to top. So there's this recursive package that I just mentioned. It contains these nested lists, for example, the Star Wars list. So that can be a nice resource using that package and using that list, and also seeing her documentation about it, like some convenience functions to deal with these lists in a more comfortable way. And she also has this purrr tutorial. And of course, I'm going from bottom to top, the R for Data Science book, it was already mentioned. Billy Kisu posted the link in the chat, so thank you for that. It has a dedicated chapter on iteration. It doesn't start out with purrr, it introduces iteration slowly, also Apply and friends, but it also mentions the purrr package, and it's a nice introduction, very gentle, not too complicated, and gives you the key ideas. And of course, you have the RStudio cheat sheets. I don't know if you're aware of these cheat sheets. It's nice when we're not in a test or exam situation that cheating is allowed in the sense of using cheat sheets. So in RStudio, you have this help menu, and there's an entry cheat sheets, and there are a number of cheat sheets there. There's even a direct link to the purrr here directly in the menu that you can access from there. But on the slide, there's also a link to a cheat sheet that gives a very concise overview. I think 2 pages, just a simple PDF that you can print out and stick to your wall to have an overview of purrr functions. Okay, Yignesh says, please share a GitHub link if possible. Or you will get access to this presentation. So all the links that are here, you will get. So I will share this in PDF format, and you will have all the links there. Or did you refer to a different link, Ignish? I think, yeah, all the links that you see here, you don't need to write down. You will get them after the presentation. Right. That's basically it for the slides. I have more code that I'm happy to share with you, but I think it was a lot of information now. So I don't know if you like, we can have a short break maybe to refresh a little bit. We can have a discussion if you like, just like how you approach topics like this, if you find this helpful, if you plan to use it, or if you're doubtful. Okay, I get Ignish is posting in the chat, thank you. Yeah, that's nice to read, so you liked it. So if there are no urgent questions now, maybe we have a short break to refresh a little bit, and then we can have an open discussion. And if you like, we can also look at more codes like the plotting example or more per functions. I have 2 more scripts that we can go through if you like, but maybe you'd prefer to discuss, so we can do that after the break. So I don't know how you feel, how fresh you are.
All right. Thank you so very much. I think you can have a short break now.
Okay.
Thank you so very much.
I don't know what you're used to. How long shall we make it? 5, 10 minutes?
5 minutes is okay.
5?
Yes.
Okay.
Thank you.
Right. So grab a coffee or refresh in any way you like, and see you back in 5 minutes. Right. I think it was 5 minutes now, so I hope you're back. We have some more time to spend on questions or more code examples. There was one question in the chat that I missed before the break from Benson. Is code maintenance easier when using a functional style? A very good question. My short answer would be, of course, yes. A key idea in functional programming, or in programming in general, is the so-called dry idea. I put it in the chat. Dry, but not as in lack of water, but it's an abbreviation for don't repeat yourself. So maybe I go back in the presentation to a slide more at the beginning. Here, one of the first slides on the right-hand side, where we use the sample function multiple times. In this case, 2 times, but of course you can imagine doing it more often when you want to create more words. So sometimes it's tempting and it's quite easy to just copy and paste a block of code and to make small adjustments, like one little change, maybe using a different seed or changing the size, the word length, something like that. And you just copy and paste your code, make a little adjustment, and then you get the results you want. So that works, but I'd say this is quick to create, but it can bite you later on when you have to maintain this code. There's another message in the chat. Victor, thank you. I will refer to that in a moment. Using copy and paste, I think, is fine because it's quite quick to create code in this way, and it's quite easy. You don't have to think too hard, and you make little adjustments to your code. But as soon as you have to make changes, you may find yourself in a situation where you have to make the same change in several parts of your code because you copy and pasted that. For example, if I don't use the sample function from base R, but maybe one of the sample functions from dplyr, if I exchange that, I would have to make that change in several places. And the idea with dry, don't repeat yourself, is that you write code in such a way that every piece of information is just contained in one place in your code. And if you have to change that, you only change it in one place. And that makes maintenance easier, I would argue. So a typical example would be when you recode something and you recode different columns of your data and you write one line of code for each column, you make mistakes with copy and paste. And then you know how it is in practical life. Many times when you have to make changes in several places, you find all of the places but one. And then you wonder why your code doesn't produce the desired result, or why you see an error message, and it's just the one last place that you missed or one wrong change that you made. So it's better to have to change only one part of your code. So when we extract out functions like we did here, like if we change the word length now, we can change it only in one place or make it a function argument, and we don't change it in several places. Now, Victor said, I find debugging more difficult with functional style. Okay. I think it's easy to admit that functional style can be a bit more challenging, especially if you just start out and you're not so experienced, but also when you're experienced. I don't know, Hadley has given a lot of presentations and written blog posts, and you often find him admitting that he makes a lot of mistakes and he takes a scientific approach to fix them, but it doesn't mean when you get better that you don't make mistakes anymore. You will always make mistakes, and the question is how to find them and how to fix them. So yes, debugging I think is a challenge, but with functions, you can develop techniques to help with debugging. An advanced topic that we can't cover today, but that is one of the topics that I give workshops for, is creating your own R package. And then debugging is even more challenging, of course, as your package grows. You don't want to introduce errors that you don't see at first glance, and then you publish your package, and then other users will find the errors, and that's of course not nice. So there's a package that helps with debugging. I put that in the chat. It's called test that. So you can write functions that test your code. You make certain assumptions of about your code, and you can test these assumptions. And whenever you make changes in your code, you can run all these tests in an automated way and see if the assumptions still hold, or if by accident you introduced an error maybe of something that used to work before. Hadley was motivated to start with the test that package because he said he found himself fixing the same mistake several times. Like you fix a mistake and then you make other changes in your code and suddenly you reintroduce an old mistake. And when you have your testing automated, you will find that very quickly, and finding an error quickly also means it's easier to fix because then it's fresh. You just made a change and you can easily see, more easily see what this change actually did. And it's easier than maybe finding an error 2 weeks later when you don't remember what the heck you changed. Then debugging becomes harder, of course. So you can look at the test that package. There are nice examples. For example, the string R package that I mentioned has a lot of automated tests. And the nice thing is that these packages are also on GitHub, so you can see the source code of tidyverse packages and how they deal with debugging and with automated testing. So they're quite nice examples that we can learn from. Right, Victor, I don't know if this was a satisfactory answer to you. Do you have an example, maybe something lately where you struggled with debugging, or what are typical challenges that you're facing with debugging or with functional programming? Okay, thank you. Right, so we're now in a question and answer session. I don't know if there are more questions. That was one question from before the break. Are there more questions now, maybe about the code or about other topics, or any experiences you'd like to share, like what you struggled with? That's something that I would like to know. For example, what do you see as, what are your struggles in R programming? What are topics or tasks that you struggle with? And do you find that a functional programming approach helps there?
Thank you so very much, Wolf. Do we have any question? Participants, are we there?
Maybe I can add a little to Victor's question or a statement about the challenge with debugging. I think a good approach is when you write functions, when you get into this functional programming paradigm, to make your functions simple. It can be, maybe it's tempting to have a great idea and to start out with a huge function that does a lot of things. And then you will find debugging hard because your function does so many different things, and maybe it's hard to test the function under different conditions. So it is a good idea, I think, to make your functions very simple. So the goal should be that one function solves just one problem or one task. And if you need to solve several problems, then write several functions, one function for each task. And then you can have like a meta function that just calls your sub functions. And code that is organized like this should be easier to test, because for each small subset of your problem, you can test if the function does what it is supposed to do, and then you test the next step, the next function, and then debugging should be easier than when you have one large function that does a lot of things in one place. And then, of course, debugging is harder. Right, okay. Okay, there's a question about the pipe operators, the Magritte dplyr pipe and the base R pipe, if they are the same. Strictly speaking, no, they're not the same. For simple cases, they behave in the same way. Let me have a look at this code here. You see this function here, myCSV1, that we saw before the break, where I filter the diamonds data set to store separate CSV files. And there's this line 47 here that builds up the file name. I use a function from the stringer package to paste together this, file name as a string. So it has this prefix diamond cut and the file ending, the file type .csv. And in the middle, I use this dot notation to refer to the data object that I'm using. So the pipe inserts the data object or the result from the previous line as the first function argument by default. But if you want to insert in a different place, like here, you can use the dot notation. And I think this dot notation is not possible in base R with the base R pipe that Naim will put first in the comment in the chat. The base R pipe doesn't accept that dot notation. There's a workaround. I haven't used it, to be honest. There were different solutions to that, and I think they're working on something more general. I don't know if it's published yet. I haven't checked that. But as long as you don't use the dot notation for special cases like here, if you just want to pass on results of calculations from one line to the next, like in my early slides here before we introduced purrr, you can just use the base R pipe or the Magritte pipe, and they both should work the same way. Oh yes, Victor, thank you. Yes, the underscore placeholder. I think I read about it, but I haven't actually tried it out. So that's right. So the syntax is a little bit different than with a Magritte pipe, the dplyr or tidyverse style pipe, but it is possible to deal with scenarios like I just showed you with building up the CSV file name. Yes, so it's, thank you, Victor. Okay, Abraham says trace back for debugging. Yes, that's a useful function, of course. There's also a debugging mode in RStudio. You can use the debug function or debug once functions. So there's some tools in RStudio to help you with debugging. That's also a topic that we could look into, maybe not today, but at some point. Right, maybe a question to all the participants and also to the organizers specifically, how we spend the rest of the time. I think if I remember correctly, the plan was to have half an hour more for a presentation or more purrr content, and then half an hour for discussion and use cases. So I have more scripts to show you, but I'm flexible, and what you find most interesting, we can do that. Right, so would you like to see more coding examples relating to purrr, or just finish completely, or what was the idea now? I'm not sure.
No, we want more from you, because it's going to really answer questions by some participants, especially from the United States, that their timing is kind of conflicting with ours here.
Yeah.
So they're going to have a view of the video recordings later. So that's why I want everything to be complete. So,
okay.
Thank you. So you can go ahead.
Do that. So thank you very much, Kiso. So we can add up to what we already saw and talk more about the walk function, a variant of the map functions that can be used to call functions just for side effects and not for the actual return value of the function. We discussed that when we saved the CSV files, and we talked about side effects there. We said saving a file to disk is a side effect and not an actual return value of a function. And we saw that the map function or lapply would do the same, returned a list to the console, and we saw the subsets of the data running through the console, but we didn't want that actually, we just wanted the files saved on disk. So that was an example, a use case for the walk function. And now I want to show you a similar example for creating plots. So I think this is quite practically oriented. It's a bit similar to the CSV file example, but maybe easier for some of you to relate to that. So plotting is a very common task in data analysis. And here we want to create plots for subgroups. Of course, we can use facets in ggplot2 if you're familiar with that. But here, let's say our task is to really create separate plots, not one plot with different facets. We need separate plots and maybe save them and use them in separate places. So again, I'm using the diamonds data set to make it easier. I'm cleaning up my global environment to make it easier. Also start a new session. Fresh start is always a good idea. So just loading the tidyverse. And you see the purrr package is part of the tidyverse, so I don't need to load it separately. And using the diamonds data set again, and because it's quite large, to reduce plotting times, I take a sample from this, 10% sample, using multiply function sample frag. So instead of 53,000 cases, we just have 5,394. And now let's say we want a plot just for one type of clarity. Diamonds come in different clarities. We can look at the clarities. You see there are 8 categories in this variable. So we have 8 different types of clarity in this data set. And let's say we need one plot for each clarity. Of course, this is a simple example, and you can easily extend that. Maybe say when you have 100 or 1,000 categories, it's still the same technique, but it would be much more tedious to do it manually. So here in the first start, I just filter manually for the first clarity I1 and create a plot from that. So you see this plot. We have carat on the x-axis and the price on the y-axis, the color by depth, and in the subtitle, it gives me the clarity, but it's hard-coded. I filtered for it here, and I put it in the subtitle. So now we could say if we need the same plot for other clarities, we could again copy and paste this code and just exchange the clarity here, like make minor changes to the code each time, but we duplicate our code and repeat the plotting code all the time. So these are the clarities. So of course, when we talk about functional programming, the first step, again, like we saw before, is to write our custom function. We can use the same code as before, basically, with a small change. We make the clarity a function argument. I call it my clarity to distinguish from the actual variable in the original data set. And then the filter function uses this function argument. We filter for the clarity that we pass the function. And also in the subtitle, we want the correct subtitle, so we can use the glue package. We could use base as paste function, but then we would have to close the quotation marks to add the function argument, and with the glue package, we can use this curly brace notation inside the quotation marks. We don't have to close the quotation marks. So we have that. Now I have a custom function, my plot, and I can use it by passing clarities, the function argument, and I pass it as a string. So to create the same plot as before, I can delete the plot here so that you see it, it gets created again. I just write my plot and then I pass the clarity. So of course now it's only 8 clarities, I think. So I could create 8 plots from 8 lines of code. That's much less duplication than if I copied the whole plotting code 8 times and just changed the filter here. And of course the subtitle. So now it's just 1 line of code, But if I want to create 8 plots, it's still a bit of duplication because I would call my plot 8 times. And to make it even shorter, I can create a vector of clarities. I call it my clarities, and then use that. And now we don't need tidyverse to do that. Of course, ggplot for the plotting, but I can do it without purrr. I can use lapply and just pass it the vector of clarities and the plotting function. So it's possible using lapply, and you see a similar thing as before. First of all, of course, we get the plot. So in the bottom right pane, you see the plots, and I can navigate through the plots, and you see really that 8 different plots have been created. But also in the console, you see these list indices with the double square bracket notation. Here, we don't see any results. The list is empty, but still it is a list, even if it is an empty list. But the console displays these 8 list indices. So maybe working interactively like this, we don't worry too much. It doesn't disturb us. But let's say you have a markdown report maybe that you create, and if you had these results in your markdown report that are basically meaningless, and these list indices, it would not be pretty. So we're looking for a way to avoid this output and to just call the function for the side effect, like we did with the CSV files. So we just want the plots, only the side effect, and not the list that is the usual return value of lapply or map. So again, I can delete the plots, and I can change lapply for map, and map works like lapply, and again, I get the list elements, and again, I get the 8 plots. So 8 plots from one line of code is quite elegant, and it would work exactly the same if I had not 8 categories, but maybe 100 or 1000. The code would still be only one line. But now you guessed it probably if you paid attention to the CSV part before we exchanged the map function for the walk function. I delete the plots again to check if the plots are created, and I call walk instead of map. Here, notice I wrote purrr double colon to show that the walk function lives in the purrr package, but of course the tidyverse is loaded already, so it would work without specifying purrr here as well. So I do that, and you see we have no output in the console, which is nice, but we have just a little problem. We also have no plots, so that's not so nice. So there's a little trap here. Maybe if you have written loops and created plots inside of loops, you will have seen the same phenomenon. You need to call print explicitly to actually create the plots. So walk takes a function, so we need this function notation with the tilde, or we could also write the base annotation function x, and then the plots are created. So let's do that. And it takes a moment, but now you see in the plot pane in the bottom right, the plots are there. The plots have been created, and there's no output in the console. We don't get this list. We get a silent return. And I can also use the space R notation function x. And also, who was it in the chat a couple of minutes ago when we talked about, can't see it in the chat now, when we talked about anonymous functions, R41 introduced this notation with the backslash and the x as a shortcut for function x. So I delete the plots one more time and run this last line of code, line 59, call the walk function again on the vector, my clarities, and with this anonymous function that prints the plot and calls the myPlot function. So let's do that. And also this works. So we basically have 3 lines of code that all work, and we can choose which one we find convenient. Line 53 with the walk function and the tilde notation, line 56 with the base R notation function x, and then the print myPlot function. And lastly, the new shortcut for function x with a backslash and the x. So this is another success, you could say, from the tidyverse team introducing a shortcut. And you know that base R is developed very conservatively to preserve backward compatibility. So it's very rare that you see changes like this in base R. But this anonymous function shortcut was such a good idea. They thought that base R also got a shortcut for anonymous functions. Print could have been called inside my plot. You can try that out, Victor. I'm not sure. I would have to try that out. Or have you tried it already? It's always a question where you call the side effects. Yeah. We'd have to try if that works. But I think this is more natural to make it explicit that I want to print here in the walk call. Because when I read the code, this is where my attention would be focused on. My plot has the details, but here I say that I actually want it printed and not maybe saved as an object. Right, and that's basically the third of the 4 scripts that I wanted to show you. So the time is moving fast. I have one more script, but I'm not sure how fresh you are, or maybe if there are questions about this script. I think it's very similar to the CSV example that we saw before. It's the same idea. Here we iterate just over 1 vector. In the CSV example, we had 2 vectors, so here it became a bit simpler, but it's another example for side effects of functions. Storing on disk is a side effect where you don't want a list as a return value, and printing a plot is also a side effect where you don't want a list as a return value. Right, so much for this example. So if you like to practice that, you're welcome to pick any data set of your choice and maybe create separate plots for different categories and apply this technique that you saw here, putting your plotting code in a custom function and then calling that function using map or walk or add apply if you don't mind the list. Right, any questions about this code? Anything that you found noteworthy or that is not clear? Anything that confused you? Doesn't seem to be the case. Okay, you can still ask questions later if you can think of any. So always welcome to interrupt me or use the chat. Yes, Babatunde.
So I tried Victor's suggestion of adding print to the function of my clarity, but I guess the side effect is not really what really got printed out. What I mean by that is anytime I execute the code using the walk or the apply, I still get a list of the plots is the output now on the console. So I think it will not be a very nice idea to put the print function call in the function itself.
Oh, okay, I see. Okay, yeah. Yeah, so it's better to have it in the map or walk call. Yes. Okay. Yeah, thank you. Great. Yeah, it's nice to see you so active and trying the things out. That's good. Right. So there are no more questions. Maybe just for the last couple of minutes, I have a few more code examples. I know it's a lot of content, so I wouldn't expect you to remember everything by heart, but if you just remember what's in the scripts, you can always use the scripts as a template and look things up. So I think nobody expects you to remember everything now by heart, but maybe it's nice to just get an overview of a couple of more functions that we haven't talked about yet so much. So purrr, as I said, it's really a bit surprising seeing how powerful it is and that it has been around for a couple of years. Seems to be a bit under the radar, and some of its functions are quite little known, I think. So I'll just show you a few more. One typical use case that you sometimes have is that you call a function like base r's mean function, and you have to specify parameters very often. For example, typical case in the mean function is if there's one missing value in your vector or in your data, the result of the mean function is NA. So it's very strict in that sense, and you have to specify NA.rm equals true to remove or ignore missing values and get a valid result back for the mean function. So if you have a lot of calls to the mean function, you always have to specify this parameter if you want to ignore missing values. So it can be handy to have a shortcut to say, when I call the mean function in this script, I always want missings to be ignored. So there's a purrr function called partial, and the thing that maybe takes a moment to wrap your head around, it doesn't make a calculation, but it returns a function. So you can have functions that return functions. So partial uses the mean function, and when you specify a parameter in the call to partial, you get back a new function with this parameter fixed already. So if there's any function with a default parameter that you don't like, you can use partial. So here I create a function that I call mean NARM using partial and setting this parameter, and then I have a function that always ignores missing values and yields a valid result. So I just run this code, and I hope you see what I mean. I pass it a vector that contains a missing value, and here I don't have to specify this parameter na.rm anymore because it has been fixed in this mean NARM function. And you see that mean NARM appears in the environment as a function. So I can type the function name, and the object type indicates it comes from purrr's partial function, and it says mean NARM is true. So it has this parameter fixed. Okay, and then there are a couple of functions that make it easier to work with lists. So we can have a quick look at that. Maybe just keep in mind that you can find these functions here. You don't need to remember them all by heart. For example, when you have a list that contains empty values or null values or values of length 0, like here, B, you can simply use the compact function to exclude them. So you see we get a compact version of this list back, and now B null, this element is just dropped. Flatten is similar when you have a list with too many levels of hierarchy. For example, here, I use the rerun function. It's also in the purrr package, maybe not so well known, to run the sample function twice, and I get a list back, which is not so convenient to work with. So I can use the flatten function to get a vector back that contains all the results and is more convenient to work with. Okay, maybe lastly, and then we see how far we are and how tired you are, because I have a few more examples, but maybe it's enough then. But these last two, safely and possibly, I think I can show you quickly. Sometimes you may have that issue that you have calculations that sometimes fail. For example, the log is not defined for texts. So when I run this log function, I get this error message. And when that is in a script or in a Markdown document, maybe the script stops and I get this error message and no more code is executed. So maybe sometimes I know that I can do calculations and they work most of the time, but in some special cases they will fail, but I don't want my script to interrupt. I want a better error treatment. So I can use the safely function from the purrr package, and like partial, it doesn't do a calculation, but it creates another function. So I call this function log save, and I just use the safely function on the log function from base R. So let's see. And then I can run log save on text. And now instead of an error message that stops my script, I get a list back with 2 slots. One has a result and one has an error message. So you can easily imagine if you have more calculations to do, you get a long list and all the results are stored in the results slot. And whenever there are error messages, they are collected in the error slot, but the script doesn't stop. You can still run the script even if some of the calculations fail. And very similar to safely, there's also a function possibly in purrr, where you can specify an alternative value whenever a calculation fails. So the argument is called otherwise. I think that's quite intuitive. And I say, if the calculation fails, I want just an NA value. So now I can use log on the text again. And instead of giving an error message and stopping my script, I just get an NA back. And I can also specify any custom message for otherwise. So here I can say, when I want to take the logarithm of a text, it doesn't make sense. So I can make R, instead of creating an error message, return doesn't make sense. But my script doesn't abbreviate, my script doesn't abort. For example, if this is in a Markdown report, I can put a custom message in a Markdown report, but the report is still created and execution doesn't stop there. Right. Time is almost up. There's more code, of course, but I don't know if that would be too much now. I'd be happy to continue, but I'm not sure how you feel. So maybe let's have a stop here and maybe open up one more time for questions, discussions. Any direct questions relating to the code that you saw today? And if not, then I'd like to know, those who have not used the purrr package before, from what you saw today, if you can imagine using it, or if you're still a bit hesitant, how do you feel? Are there some things that you can imagine using, or is it something that you don't see coming up for your own projects? How do you feel? Some of you have used it before, I think, from what I read in the chat before. So there were some advanced use cases mentioned. So I'd like to know, for those who are more experienced, have you seen anything that you weren't aware of and that you can imagine using in the future? Yes, Babatunde?
Once again, I'm really grateful for this session, and quite funny. I've been using the work, I use the P work, and safely, it's like mind blowing for me, because I engage in writing some functions, and you have some function that actually works with users' interaction.
Mm-hmm.
I want to predict what the user will interact, user input might. Possible, what the error, a more user-friendly. So I think it's powerful to know that this function actually exists, and I'm surprised I don't know about this before. So again, thank you very much.
Yeah, thank you for your feedback. Also, Ignace wrote, We need to practice. Yes, of course. Unfortunately, practice is, I think, not avoidable. I feel the same, and I'm also surprised that some of the functions are quite little known and are not very common.
All right, thank you so very much. Do we still have other questions, please? Okay, in the absence of none, sorry, Wolf, could you please share with us the slide, the updates, and the entire code for this presentation, please?
The code you should already have.
Okay.
I just showed you these 4 scripts, and they are both in the RStudio project and also in the separate download folder, the GMX cloud. So you should have the code and also this data set with the magic numbers if you like to experiment with that a little bit more. And the slides you have not got yet, but I will make them available also in the download folder. And I don't know, Bilikitsu, if you can also spread them via email. That depends on you then which ways you choose, but yes, I will make them available. I was just a bit hesitant because I found with presentations in the past that sometimes I made 1 or 2 changes, and then there are different versions around, and people mix up the old and the new version. So I wanted to make sure that you get the final version. But yes, I promise I will make these slides available as a PDF.
All right, thank you so very much for that. In the absence of any other questions, I would like to say a very big thank you to Wolf for this insightful presentation, as on behalf of Bilikitsu, the organizer of Abuja Ariza Group, and all the co-organizers as well. So also we'd like to appreciate our participants for their contributions and for staying with us from the beginning till the end of this presentation. Thank you so very much. And we also hope to see you in a subsequent webinar. I don't know if we still have any other thing to say, Wolf?
Yeah, maybe also a big thank you from my side. I really feel honored to be invited. So it was a great pleasure for me. Thank you to Bilikitsu for all the work, and beforehand, and the communication was very smooth, and I felt very confident and happy going into this, and also to the co-organizers that probably did work in the background that I didn't see or wasn't aware of. I was really amazed by the number of registrations, so maybe more people will watch the recording. I hope that comes across okay, and I hope you can make use of some of the functions that you saw today, some of the tricks, and I hope it will help you in your projects. There's another, on my GitHub profile, yes. My GitHub username is Fyodor. I put it in the chat. So github.com Fyodor. You'll find some of my projects. I have some private repositories for training, so not everything is available, but the meetups are available. This is, I think, the 3rd meetup that I've presented at, so you also see code for the other meetups on my GitHub profile. I think that's a public repository, so yeah. I'm active on LinkedIn, so Bilikitsu did a lot of work for this webinar to make it popular on LinkedIn, so that was very nice to see. I have a YouTube channel if you like to check that out. There's also a video about the magic numbers, but about a lot of other topics as well, like speeding up R code, running R code in parallel, some plotting visualization tricks and so on. So you'll find a couple of videos there. I also have a Twitter handle and a Facebook page, but it's not so, don't do so much on Facebook. Twitter a little bit more, but yeah, maybe the YouTube channels may be most useful to you. Babatunde wrote, if you're familiar with the purrr package, yes, the purrr package is a very good hint. I haven't prepared anything for that today, but it's a very good extension to purrr. So I don't know, Babatunde, if you want to speak about it, if you've used it. I haven't worked much with it, but I think it's from Henrik Bengtsson, who has created the packages future and some packages around this future concept. So you get functions that you can run in parallel. And the nice thing about future and purrr is that you can use different backends to run code in parallel. Right, so Babatunde, if you like, you can speak more about purrr if you know more. It's a powerful extension to do the things that we did today, and run them in parallel and give the user power to use different backends for parallel code execution. So if you have big data and large runtimes, and then the purrr package is a great way of extending on the purrr knowledge.
So true, Wolf. So true. I've used the purrr package, and to be honest, it's powerful when using it, especially when you want to keep the user engaged with a long computation, and you don't want the R session to freeze up or hang, and while other things are being done in the background. Also, it makes use of the old processing power for your PC, or if you are running it on a server, so you can use more RAM, you can use more cores and the likes like that. So I guess it's very wonderful.
Yeah. Yeah, thank you, Babatunde. I don't know, maybe before we finish, just one addition to one of the questions that came up in the chat before. It was about debugging and if functional programming style helps in debugging. And there was some doubt, like sometimes debugging can be more challenging in functional programming style. And that's true, depending on how complicated your code is. Maybe one last example, it's in your script, Abuya 4, further purrr functions. So the last thing we'll do now is to compose a function. And that's a very simple example, and I hope you see very quickly how this functional style can help in code maintenance. Let's say I have several lines of code that just round some values. So I combine the round and the mean function. So I calculate a mean and round it. So very simple code, and copy and paste, of course, for different numbers. And then let's say somebody says, okay, we don't want to use the mean anymore. The data is very skewed, not normally distributed, and it's better to use the median. So if we have used the mean function in several places, we have to change it in all of these places to turn it to the median. So we have to make 3 changes in this simple example, but you can easily imagine there could be 50 or 100 changes. So it's better to only have to make this change in one place. And of course, you can do that with base R and write a function that combines median or mean and round. But with purrr and compose, it's even easier. You just write compose, so you can feel like a real composer, and you compose a function that combines round and mean. I call it stat round here, and then I just apply the stat round function to do this calculation. And now when somebody says to me, don't use the mean function anymore, but use the median, then I only have to make one change in one place and not in several places. And I think you see that code maintenance is easier that way in this functional style, and here even more convenient using compose and not writing our own full custom function. Right. The last part of the script, I think we won't do now. I have the feeling that it has been a lot of information already, and we've had some thank yous and like final words already, so I won't do that. Just a mention, if you work more with lists, you can check out this last part of the 4th script. There are some coding examples to work with the Star Wars lists, and you can see how you can use purrr to access elements from this list more elegantly. But I leave that for you to explore now. I think it would be too much now. You can just try out this code and familiarize yourself with it. If you work with lists, I don't think that everybody will have this task working with nested lists, but if you do, purrr can make your life easier as well. Right, I think that was it from my side. Thank you so much once again. I really enjoyed this. I hope you did too. Thank you to all the organizers, and all the best for your R projects, for whatever comes up. Not only R projects, of course, but particularly for R. All the best, and hope to see you another time, maybe.
All right, thank you so very much, Wolf. That was a very great session with you. We hope to also see you in our subsequent webinar. Maybe we'll also invite you some other time for another topic on R programming language. Thank you so very much. And to the participants, once again, thank you so very much for staying with us to this very moment. We really do appreciate, and we also hope to see you also some other time. Thank you and have a blessed day.